Oh, bud, here we are. ARP, first stop on our California tour.
I'll tell you what, it's been great. This Raptor, Ford did a great job in this truck with the big 6.2 in it.
Oh, they did, and you know, it's great to know ARP is going to build a whole new faster kit for this thing, so they want to take a look at it.
Yep, let me go ahead inside and R&D. I'll catch you later.
All right, bud, and I'm going to go over to manufacturing. I'll see you in a bit.
Okay, man. Hey, Mike, how you doing, buddy?
Hey, Sam, good to see you.
Hey, good to see you. We're here at the Research and Development Department at ARP. This is Mike Bowman. He's the Director of Research and Development. Looks like a big Ford motor here, huh?
Yeah, a 6.2 gas motor.
Ah, Raptor engine?
It is.
All right, so what are you making for it?
We're starting to work on the head stud prototypes.
All right, so tell me, what are the steps for you to do to start developing a stud for an engine like this?
Well, we get the motor in here, so we got the motor to measure, take the physical measurements off of it. And that's kind of where we're at right now. We're starting to...
I see the vernier. What are you working on here?
Well, we got a little sheet we fill out that gives us the basic measurements, the thickness of the head, the length of the thread in the block, the counterbore depth, so it gives us our basic general outline of what the stud's going to be.
Okay, where do you measure that? Down through the bolt hole?
Yeah, right through the bolt hole.
All right. Pretty good.
Pretty simple.
Now this is a fancy looking little deal. This looks like some kind of a test instrument.
It gives you, so you got enough thread on there where you can measure the thread in the block without running out of thread on the stud.
Uh-huh. So what do we do here? Screw this in here?
Yeah, well, you just set it in there first and you take one measurement to the deck.
I see.
Right.
Then you screw it down.
Screw it down, subtract it.
And measure it again. Other. The difference will be how deep the threads are in the block.
That's right.
That way you prevent bottoming out.
That's right.
That's pretty cool.
And it tells you what you got to deal with in the block, how much, because you always want to use as much thread as you have available.
Yeah, absolutely. That's great. So you can put all this on there, and then what do you do?
From here, we'll generate a little sketch or drawing that we can turn into the drafting department and get an official drawing, and then we'll get some prototypes going.
Great. Do that over in manufacturing?
Yes, sir.
And that's exactly where Dave is. Let's go see how these things are made.
Hey Sam, when you're here at ARP, virtually all these fasteners start out with something like this. This is just a piece of steel wire that comes in a big coil, but that's the first step. Chris Raschke here can tell us all about the rest of them. And Chris, once this comes in, what is the next step now?
Well, we've got the part that's been forged off the heading machine. It's been cut to length and straightened. So we're gonna take the next step and we're gonna chamfer the part. So the machine's gonna grab the part, it's gonna come on both ends, and it's gonna chamfer on the top. It's gonna put a chamfer on the bottom of the part.
Also, I noticed it's got the little Allen sockets you put in there too as well.
Yes, that's a feature that's gonna ease the installation of the stud in the final process.
Okay, now once that happens, what's the next step?
From there, we'll go to heat treat.
All right, Chris, now you guys heat treat everything here. What is the purpose of that? What does it do?
Well, we got to get the material to its proper hardness so it can do the job that it needs to do. So we're going to go ahead and put it in the heat treat oven, the IQF, and we're going to heat treat it up to say a 52 Rockwell, and then we'll draw it back and temper it back to 40, 44 Rockwell, depending on the recipe.
All right, now what kind of temperatures are we talking about in there?
1,575 degrees.
And when he's talking about Rockwell, folks, that's an indication or a measure of hardness. And you got a special device for that.
Yes.
Well, folks, after they come out of heat treat, they're checked for their Rockwell hardness, and they pass that spec. They're on to the next step, and what's that, Chris?
That's a shot peen. This is where we clean the scale off the part and get it ready for the grind process.
Now, does the shot peen do anything other than that for it?
At this stage, it does not. It's just cleaning the part up, descaling it.
All right, well, let's see what this happens here. All right, so this is where it's done?
Yes, it tumbles the part, and the media is thrown at the part inside until it cleans it all up.
And how long does that run like that?
About 7 to 8 minutes per load.
And when it's all done, what do you got?
We've got a nice, shiny, clean part.
Okay, now after they leave here, what's the next step in this process?
We'll go over to the straightening process.
Well, you know, having your pieces straight is really important, and Chris, that's what this station is, isn't it? Straightening the
This is
run.
straightening the part. Yeah, we apply the part between two flat rollers, and we actually put pressure on the part and roll it through, and that straightens the part, preparing it for grinding.
All right, now I know quality control is always here. That's what you're doing over here, is checking for straightness, right?
Yes, every part, or a percentage of the parts we check to make sure they are straight.
Okay, now once they come out of here, what's the next step?
We're gonna go over to grinding.
All right, Chris, we came from straightening, and this is an example of what comes out of there now.
Yeah, the part's a little rough, but it's straight enough to go through our centerless grinders.
Okay, so now from this point, we're here where you grind them. Now, what's the grinding process on
Well,
it?
we'll take this part and we'll grind it straight for 2 separate complete grinds, and then we'll do the TD grind, which is the grind to get the dimension for the thread rolling process.
Okay, and I can see just a little relief right there, so that's where they do that's the thread relief, right? Okay, now from this point on, where does it go?
They'll go over to thread roll.
All right, we're here where they put the threads on our studs, and you can see here, this is before, and of course, this is after. But these threads are rolled on, and Chris, that's important. Why?
Yes, because it's a forging process. Basically, we're pressing the thread into the part, and it makes a better part, it makes it more consistent, has a lot greater fatigue life in the thread.
And I notice it's nice and smooth, too, when you roll your finger over it, as opposed to sharpened, like, you know, if it's been cut on there.
Correct.
All right, so from this step now, we're almost done, I guess. Well, we put the black oxide on there and test it. We're in business.
Yeah, we'll go to black oxide, we'll go to tensile fatigue testing, and take it over to shipping.
All right, we're going to take a short break. When we come back, we got a lot more coming here at ARP, so stick around.
This edition of Motorhead Garage, presented by ARP, is being brought to you by Original Parts Group, the world's largest source for GMA body parts and accessories. Custom Auto Sound, the originator of classic car OEM fit radios since 1977. Race Gas, get more out of your engine. And by ARP, the world leader in fastener technology.
Welcome back to Motorhead Garage. Well, Mike and I are here in the R&D Center, going to do some testing now. What we've got is a stock Ford cylinder head bolt, and this is the head to block for the 6.2 Raptor motor. And, you know, this is brand new. It's a pretty crude looking thing. What ARP wants to do is develop a stud that'll give you more clamping force, and that's what it's all about, holding things together, right?
It's all right.
So, Mike's got one chucked up here in this machine. Tell us a little bit about this tester.
Okay, it's a machine that measures clamp force. It's a 60,000 pound load cell with a 300 foot-pound torque transducer. It's controlled by the computer, so we can program in the factory torque tightening procedure.
Is that what you got right there?
That's right
Let me
here.
see that. So if you had brand new at the factory, or if you were in the field, you had the service manual, you're looking at 18 foot-pounds, then 44 foot-pounds with a torque wrench. Let's go ahead and turn this thing on. Then after it reaches the specified torque with a torque wrench, then you use the torque angle gauge. You go 90 degrees and 90 degrees. So basically, 44 foot-pounds in 2 stages and a half a turn.
That's right.
Can we see that doing its thing? And we'll know then, when it's all done doing it, what the
one more
factory Ford bolt gives us for a clamp load at that torque.
Right at 15,000 pounds.
15,000 pounds of pressure. Okay, so with this information now, if you want to build a prototype, you know, you already measured the block, so what do we do next?
Well, we know from that clamp load, we got some rough numbers here that we know we're going to have to use ARP 2000 to give them a 15% increase over what the stock bolt is.
Right, and you develop your own torque spec.
That's right. Once we have
That's why you always read what they recommend. They develop their own torque specs. So what we're going to do is get this prototype made right now. Let's see what Dave's doing.
All right, we're here in the R&D Center with Mike Hosapple, who's also the president and owner of ARP Fasteners. And Mike, we just went through a whole process here of manufacturing the prototype. Now the next step is to test it. And tell me what we're seeing here.
What we've done is we'll take the finished part. You've gotten it through the shop, you've made it through heat treat, rolled it, and we bring it in here, put it in these fixtures. And this tensile test machine, what it does, has hydraulic power that pulls the part in two. So what we'll find out is how much load this stud will take. When it's pulled, it proves out the heat treat and the stresses that you put in it from thread rolling, and it should all meet our expectations of.
Now this is an example of what we're talking about right here, and you can see it pulled apart right there in the thread, which is probably the thinnest part, right?
Right, smallest diameter.
So what kind of strength did it take to pull this apart?
That took about 44,000 pounds to pull that part and break it, and which equates to about 223,000 KSI on that particular stud.
So what you're really wanting to find out is you want this to be able to break at a certain point.
Yeah, we want it to break in the range of, say, 220 to 240 KSI. And if it gets much harder than that, the part might become brittle. If it's too soft, it won't carry the load. So we've got to meet that window, just that little area.
So that's why they do the testing on that. Now that's just one test that you do here. You do several others as well.
Right, we do fatigue testing, which will take a stud or a bolt. It'll take it up to a given load. Say on this bolt, it might be 30,000 pounds, and then it'll release it and only leave 1,300 pounds of preload on it. So that way the thing is fluctuating between 1,300 and say 35,000 pounds, just constantly back and forth, and it does it about 8,000 times a minute. And we'll try to go in the neighborhood of 1 million cycles depending on what we're looking for out of that particular part.
Okay, well now you can see what kind of testing it takes place in here, but once it's done in here, then it goes back to R&D.
You know, just the appearance alone, look at this compared to the factory bolt. Now, this new ARP prototype stud, you saw what Dave did. That's testing the tensile strength, that's a tensile test. Then what Mike did, chucked it back in this machine, and he applied torque to it till it yielded. Now, that tells you where the material yields. What do you do with that information?
That's the first step in determining our torque recommendation for the new part.
Okay. So ARP supplies their studs and their bolts with a torque recommendation based on their testing. And by the way, all of this torquing is done using their ultra torque fastener assembly lube. That way it's consistent throughout the range. So now we've got a brand new prototype stud in here. And what are we going to do? Apply how much torque?
We're looking at about 120 foot-pound to give them a 15% increase over what the factory bolt did.
Okay, let's go ahead and torque it. Now, at 120 foot-pounds of torque is what the machine is going to apply. If you take the factory spec with the 290-degree turns, it's about 106 foot-pounds, so you're not exceeding it that much. And the machine's torquing it, and we'll see what the results are.
Well, we might be a little high there. We got 19,353, so we're a little over so we might back that down a little bit, adjust it, you know.
Great, but that's way over. That's more than a 15% increase.
Oh, yeah, that is.
All right, we need to take a quick break. When we come back, we're going to show you some real-life tips as we install this in that Raptor 6.2. Don't go away. Boy, what an improvement. These are beautiful.
Yeah, a little nicer than that factory bolt, huh?
Absolutely. Welcome back to Motorhead Garage. Well, we're back from all the testing, and we've got the prototypes. These studs look great. And this is where Mike plays in his R&D place, and I call it playing, but you have a good time here, don't you?
It's very enjoyable.
Absolutely. So this is just a trial fit now to make sure in real life it fits.
Right.
All right. So now a lot of times people put studs in first, but you like to do it a different way, don't you?
Yeah, we don't recommend that. Main reason being you screw all the studs in first, then you got to fight this heavy head over them. You run the risk of shaving aluminum in the top thread and getting debris in the motor. Plus, it's just easier to do it after the head's in place.
Cool. And again, this is a used motor that you took apart, and of course we're going to put the head gasket on for dimension only, but obviously it's an old head gasket and nice and clean. All right, and then we'll set the cylinder head on, and then you're going to put the studs in, and what are you going to check for?
We're going to check for the protrusion through the nut and thread engagement, make sure they're threading in all the way to the depth they should.
Cool. All right, let's lay this head on it. Now this is neat. I didn't realize these things have got twin plugs.
Twin ignition, Hemi head.
Hemi head. That's awesome. Nice aluminum casting. You ready to go?
Got her.
And of course, these engines are variable cam timing engines. They got cam phasers on them. But look at how nice it's made. The big, beefy rocker arms.
Beautiful valve train, beehive spring.
Oh yeah, from the factory.
Yep.
Beehive springs. I haven't been inside one of these motors. Nice rugged rocker arms and rocker arm shaft, like a girdle on there. Boy, that's neat. All right, let's go ahead and put some studs in. Now, you know, a lot of people put assembly lube on. Do you need any on the threads going into the block?
You know, a little bit of oil's a good idea on the bottom end, but since they're not under any friction because they're static in place when you tighten them, it's not that critical.
Okay, now they do have a hex key socket broached in the end of it. What's that for?
That's to thread them in with, and really an easy way to assemble a motor with a set of studs like this is to apply your lubricant, your ultra torque lubricant, to the stud, top of the washer, put a little inside the nut and on the face of the nut, thread it on, and drop the whole thing in as an assembly.
Oh, cool.
Because you got the hex to thread it in with.
That's easy. Now you put it on the threads and inside the nut together.
Yeah, I put it on everything. Make sure you got good coverage so that it smears together when you thread it together.
Well, we don't need to put any lube on just for this
No, not for this
trial.
test.
So let's go ahead and drop some of these in, and then we're going to just run them down with a spinner. And when you do that, that's a great tip. On the end with the nut and the washer, you want to put lube on the threads. You want to put lube inside the nut, on the bottom flange of the nut, and on top of the washer. But you want the washer where it touches the block to be dry so it doesn't spin. Is that right?
That's correct.
Cool. And you don't want to tighten these things down too much either with the hex, do you?
No, you just want to make sure they seat, though.
Yep. Sometimes you can run into a burr in the cast iron thread. If you're pushing down by hand, you miss it. You don't get it in all the way. Have you ever seen that happen?
Yeah, and at the point of assembly, you should have all your threads chased, blown out. Everything should thread in by hand.
Good engine builder would do that. Yeah. And by the way, use a thread cleaning tap, not a regular tap.
Right.
You don't take any metal out.
Exactly.
And of course, that's really critical in aluminum engines because, and the studs are good in aluminum engines too.
Much easier on the thread.
Yeah, absolutely. This is nice.
We generally give the part number to a thread cleaning tap on our instructions that will come with a kit like this.
And you have them too. I bought some of them from you.
Yeah.
Just like your ring compressors. Those work great too.
Oh, yeah.
So let's get ahead. Once you get your little two-spinner, let's spin these down.
There you go,
And we'll go
Sam.
ahead. I thought I was going to make you work, going to make me work. All right, we're going to go ahead and spin these down. In the meantime, we got to take another quick break. We'll see you right after the break.
This edition of Motorhead Garage, presented by ARP, is being brought to you by Warren Diesel, doing our best to bring you quality parts at an affordable price. KT Performance, for all your truck performance needs. Evapo-Rust, super safe rust remover. And by Stage 8, the world's best locking fastener.
Welcome back to Motorhead Garage. Well, Mike and I are here, and we're running these things down. Now, this is not torque or anything, just a little spinner wrench here with a 3/8 drive socket on it. And we run these all down. You do take any measurements, if, from your experience, and I know you do this all the time. What are you looking for here?
Looking for like a thread and a half, 2 threads hanging through the nuts. That's what we shot for when we did the prototypes, and that's where they should be, and that's pretty much what we're seeing here so far.
Yeah, and I guess that's really not a real critical dimension. But you want to make sure it doesn't interfere with other things too, right?
Yeah, it can be. On this motor, it's really not because there's nothing right above the stud, but you definitely want some stud coming through the nut without a whole, you know, 5 threads or something sticking through it. But it's going to vary a little bit whether a guy's had his head surfaced or, you know, maybe a different type of head gasket or
Block
something.
deck, something like that.
Exactly.
Exactly. And of course, all the engine builders, they know what they're doing. But that's such a beautiful look. And they all look pretty consistent here, which means Ford did a pretty good job. And again, I'm impressed with the cylinder head, you know, roller rockers on the big cam lobes. This obviously is the little reluctor wheel for the cam position sensor. All right, so you got it covered here with the cylinder heads. What else are you making for this motor?
We're getting ready to do main studs for it as well.
Oh, really? Can I play with this?
Yeah, crank her around.
You know, I don't have one of these fancy. How come you don't have an electric one?
We got you.
You got me, thanks. I see you've been playing with the studs already. Well, look at that. Now, what's the deal with that one?
As for the oil pickup tube, it's a little special step stud with a low height nut to get it where the height's the same as the factory fastener.
Cool. All right, so you're gonna have main studs. You're gonna have the bolts that go through the side of the block here.
Yep.
It's a real stable cap, isn't it?
Yeah, it is.
So this is a great way to go. That piston oil is it's a nice engine. If you're gonna do a nice job, use the ARP stuff, and let's see what Dave's up to.
Well, folks, once our prototypes are done and accepted, they go into manufacturing, and once they leave here, this is the place they come. This is the packing and shipping area. And you can see they do all the packing by hand. Now, one thing you might want to notice on the packing here is you notice that it's got shrink wrap on it to help protect it. It's packed tight in there so it doesn't rattle around, and plus it even has a number here on the side so they can check this thing all the way back to the wire it was made from. So it's got a birth certificate. But I tell you what, Sam, one of the things about being here at ARP, you see how this product is made? It is beautiful stuff.
Absolutely. We hope you gave us some insight into just how much effort it goes into making one fastener. They do a great job here, but buddy, we are out of time.
I'd like to stay here longer, but hey, we'll be around next week. Come back and see us.